Stars are perhaps the most permanent feature of the night sky, but just like everything else in our universe, they reach the end of their life cycle. Join us in today's video as we explore the agony of a dying star that is about to be ripped apart by a black hole. Black holes are destructive demons that gulp and swallow everything and anything in their path. For stars, the misfortune of getting pulled apart by a black hole is a scary and violent one. This process, called Tidal Disruption Event or TDE, is regarded as one of the most energetic and luminous occurrences in our universe. However, they're incredibly difficult to spot. In fact, only a few of them emit the required radio waves needed to identify and understand them. Hence, each discovery of a TDE is seen as an important sighting. Supermassive black holes weigh millions or billions of times more than our Sun, and as you already know, every galaxy has a black hole attached to their center. So naturally, the story of every TDE starts at the heart of a supermassive black hole. But what exactly are black holes? Black holes are perhaps the most mysterious and fascinating objects in outer space. They're an extremely dense region in space with a strong gravitational force that not even the incredibly fast-traveling light particles can escape their grasp. Due to these enormous pulling power, it is widely believed that black holes are the most devouring elements in the universe. But in reality, they don't suck on matter any more than the Sun sucks up the planets that orbit around it. For perspective, if our Sun suddenly compressed and became a black hole, it would shrink to about 3.7 miles. However, the orbit of the planets in our solar system around the Sun is unlikely to change because the mass of the star would remain constant. The scenario for black holes is the same. From scientific observations, several stars were found orbiting a common point around the Sagittarius A black hole, which sits at the center of the Milky Way galaxy. The observations were so thorough and extensive that scientists even watched S2, the innermost star around the black hole, complete a full orbit, which takes 16 years. After collecting data about S2's orbital parameters, scientists set out to calculate the mass of Sagittarius A using Kepler's third law of planetary motion. Eventually, they found the mass of these vicious black holes to be around 4 million solar masses. This astounding discovery was a result of several years of hard work by Andrea Ghez and Reinhard Genzel. And in the end, it was enough to win both astronomers the 2020 Nobel Prize in Physics. The S2 star appeared to be quite stable in its orbit, at least at the moment. However, that could change depending on its level of interaction with other stars within the region. According to official accounts, the region where S2 is located is also home to thousands of other stars, including neutron stars and white dwarfs. When any two of these objects come too close to each other, the gravitational force between both stars causes some sort of perturbation and forces their orbits and trajectories to change. In most cases, these orbits would remain stable or possibly hurl the star far easy from the center of the galaxy. But on other occasions, the new orbit of the star flings it further towards the center of the supermassive black hole. In other words, the star is sent on an agonizing journey of doom, pain, and ultimate disaster. As the unfortunate star travels closer to the supermassive black hole, it begins to experience strong tidal forces. The process starts gradually at first, and then it becomes more violent, until the star reaches the tidal radius of the black hole. The tidal radius is basically when the difference in force from one side to the other becomes greater than the star's self-gravity holding it together. According to Enrico Ramirez Ruiz, a TDE specialist and astrophysicist at the University of California, this turbulent process will consequently lead to the star being stretched all through its direction of motion. Consequently, the strong gravitational force experienced by the doomed star triggers huge distortions, which would obviously lead to a change in the shape of the element. So, rather than remain in its usual sphere shape, the star takes the shape of a long, thin oval. This process described is what we've come to know as spaghettification. Stars have an incredible record of longevity, as most of them live for a lifetime. For example, our Sun is thought to be nearing the end of its life cycle, yet scientists still estimate that it has over 4 billion years to burn. However, the death of a star takes just a few hours. But how exactly does it unfold? And how do you spot a dying star in space? According to Ramirez Ruiz, once a star is undergoing this process of decimation, half of its materials fall in and forms an accretion disk around the star. In the end, about half of the disk-forming materials get ejected. At the same time, the black hole feasts on the materials in the disk. This powers a luminous flare that is visible in space even from far distances. Expectedly, this flare disappears as soon as the material crosses the event horizon. As matter swirls around the black hole, magnetic fields focus some of the material into a powerful jet, whose particles travel at close to the speed of light. This creates shock waves inside the jet that produce intense beams of X-rays and radio waves. Once the jet's turned off, the shock wave slowly fades. However, it is able to send out radio waves that can be analyzed for 100 years with the help of the Very Large Array in New Mexico. At the beginning of the process, the TDE looks very much like a supernova. That isn't too awkward in itself because supernovae are in fact the explosion of a star that ran out of fuel. But in truth, supernovae are quite different from TDEs. The ordinary man probably doesn't know this, but fortunately, astronomers do. Scientists employ a number of techniques to differentiate between a TDE and a supernova. The very first thing they do is to look out for a luminous flare at the center of a galaxy whose supermassive black hole was previously inactive. After that, they break down the light by wavelength and study its spectrum to identify the elements it contains. If it's a TDE, the elements observed would be very much similar to the elements in the main sequence of stars that are still burning strong. Anything other than this would suggest that the process that has been observed is a supernova. The very first sighting of TDE happened so far back as the 1990s. Back then, it was extremely difficult to track such objects in space, but with automated sky surveys now possible, the process has become a lot easier, but perhaps not as easy as scientists would have liked. According to reports, despite all the advanced sky-peering telescopes, scientists have only ever observed 100 TDEs. That tells you everything you need to know about how rare it is to find a TDE. In fact, scientists estimate that our Milky Way galaxy witnessed a TDE only once in 100,000 years. In comparison, supernovas are said to happen in the Milky Way galaxy at least once every 100 years. Despite their bad boy reputation, black holes do not offer any threat to us or our planet. In fact, their existence is more like a blessing to us because the stellar explosions that birth black holes eject elements such as carbon, nitrogen, and oxygen into space. Also, the collision of black holes and neutron stars create and spread heavy elements like gold and platinum, and other elements that are quite important here on Earth. What is more, the death of one star is the birth of another. And more importantly, the supermassive black holes are also believed to play an important role in star formation within galaxies. This dictates the rate of production of stars. This fertile corner of the cosmos has been governed by all that has gone on around it, including the behavior of the black hole at our galactic center. The director of Columbia Astrobiology Center, Caleb Scharf, explains in his book titled Gravity's Engines. According to Caleb, the pathway that leads to our world would be different or entirely non-existent without the coevolution of galaxies with supermassive black holes, as well as the extraordinary regulation they perform. So in the end, the agony of a dying star has its own benefits, and black holes are not the monstrous and destructive elements we describe them to be.